Hello. In this video, I will discuss two concepts. First, I'll talk about the price elasticity of demand, and then I'll relate the price elasticity of demand to the concept of total revenue. Let's talk about the elasticity first. So suppose we're looking at a demand curve, which is our standard relationship between the price of a product, which we put on the vertical axis, and the quantity demanded of the product at a given price, which we put on the horizontal axis. The question that we're going to look at is how would the quantity demanded respond to price change. So suppose that the market at first is at the blue dot on the demand curve with corresponding price 1 and quantity 1, and then for some reason, say price falls to some other level, say price 2, quantity 2, and we move from the blue line, from the blue dot on the demand line to the red dot on the demand line. So we have this number called the elasticity, price elasticity of demand, which is the ratio of the percentage change in quantity. So the triangle in the middle is the Greek letter delta, which stands for change. And so elasticity is the ratio of percentage change in quantity over percentage change in price. And this number shows by how much quantity demanded will change in percentage terms in response to a 1% change in price. And we distinguish between two kinds of elasticity. That number is always going to be negative, because if you recall, let's go back and look at the picture. If you recall, the law of demand suggests that price and quantity are negatively related, which means that if the price were to decrease, as in my example, quantity demanded would increase. And if price were to increase, quantity would fall. So that means that the ratio of the two price changes is always going to be negative. One of the two variables is going to increase and the other is going to fall. So one of the changes is going to be positive and the other is going to be negative. And so if that ratio is less than -1, we call such demand elastic, which means that the numerator, the quantity change, will be larger than the denominator, the price change. In the opposite situation, we say that the demand is going to be inelastic. Well, let's look at a numerical example to see what elasticity stands for. Suppose we know that elasticity is negative 0.25 and the price is reduced by 8%. First, let's answer the following question. How much would quantity demanded change by? Using the definition of elasticity, we can say that every 1% increase in price corresponds to a 0.25% reduction in quantity demanded. This is what the elasticity number stands for. We can also flip that definition to talk about reduction in prices. So we can say 1% reduction in price corresponds to a 0.25% increase in quantity demanded. In my example, the price is reduced not by 1%, but instead by 8%. So we need to scale that reduction in price. 8% reduction in price would correspond to 8 times the change that corresponds to 1% reduction in price. So the 8% reduction in price will correspond to 8 times 0.25 increase in quantity demanded. So that's going to be just 2% increase in quantity demanded. So to sum things up, if you know the price change, if you multiply the price change by the corresponding elasticity, you will know the amount by which quantity demanded changed. And the only thing to remember here is that if the price is reduced, this price change is going to be negative. So it's going to be negative 8%, the reduction in price. And so the corresponding quantity change is going to be positive. Whereas if the price change is positive, the quantity change will be negative because prices and quantities always go in opposite directions. And finally, notice that this number, negative 0.25, it's between 0 and 1. So we call that inelastic demand, again by definition. And what it simply means is that the change in quantity is going to be smaller than the change in price. Price changed by 8%, but the response of the quantity was only a 2% change, less than an 8% change. So if the change is less than 1 to 1, we'll call such demand inelastic. Price changes by a lot and quantity does not change much. If the response is more than 1 to 1, say a 8% change in price caused a 20% change in quantity, such demand will be elastic. So we're dealing with an inelastic demand here. Next, let's look at the total revenue. The total revenue is simply the volume of sales in the market. So think about it as the product of price at which the product is traded in the market times the quantity of that product sold at that price. So total revenue is just the product of price times quantity. And so geometrically, if the price in the market is price 1 and the corresponding quantity is Q1, the amount of total revenue equals the area of the rectangle under the demand curve marked by that blue dot, because the height of the rectangle is the price, the width of that rectangle is the quantity, so the product of price times quantity is just the area of such rectangle. Now, when we change the price in the market, two things change. First of all, revenues increase because, say, if the price were to decrease, quantity is going to increase. So that will result in potentially larger revenues because you'll be selling more output. But at the same time, if you reduce the price, your revenues will fall because every single unit that you're selling will have to sell at a lower price. So again, because of the law of demand, you have two opposing effects. On the one hand, lower price allows you to sell more. On the other hand, lower price means lower per unit earnings. And so elasticity helps answer which effect is stronger when you reduce the price. Do you increase your revenues by selling more, or do you reduce your revenues by charging a lower price? So let's go back to our example. Remember, elasticity is negative 0.25, that's inelastic demand. Price is reduced by 8%. We want to estimate the change in total revenue. Here's how we're going to proceed. First of all, we already know that an 8% reduction in price means a 2% increase in quantity demanded. Now we need to compare the total revenue before and after the price is reduced. Suppose that before it was just some price times some quantity. I'm not going to specify it. We don't need that information to find the answer. And then after the price has changed, we need to relate the new price and the new quantity to the old price and quantity combination. And first thing that we can say, if the price is reduced by 8%, that means that after the change, the price is just 92% of the original, because 92 is 1 minus 8%. So if you reduce something by 8%, your new value is just 92% of the original value. That's the price. Similarly, your new quantity is 2% larger than your old quantity, so it's like 1.02 of the old quantity, 102%. And so if you multiply these two values together, 0.92 and 1.02, you'll get a value of 0.9384. So whatever the product of price times quantity, that product after the change is reduced to just 93.8% of the original value. That means that your total revenue is decreased by approximately 6.16%, because 93.84% of the original total revenue corresponds to a 6.16 reduction in total revenue. But there is a shortcut. The convenience of using elasticity is that we don't need to do multiplication. When we switch to percentages and the percentage changes are relatively small, we can replace multiplication with just addition. So we have this shortcut formula that says that the percentage change in total revenue is, well, approximately the sum of the percentage change in price and the percentage change in quantity. Let's see how that works out. We know that the price is reduced by 8%, so the price change is going to be negative 8%. Quantity is increased by 2%, so we need to just add negative 8 plus 2 to get negative 6%, and we get the same roughly answer as in the original setting by doing multiplication. So whenever possible, use the shortcut and replace multiplication with addition. You will get roughly the same answer, not exactly the same, but the answer is going to be very close to what you're dealing with. Okay, thank you.